Okay, hello, good day, grade 12. So welcome to our General Physics 2 class, and today we are going to discuss current, voltage, and resistance and their relationship on how electricity works in our household. So the learning competencies to be discussed for this lecture are the following. Okay, before we start with our main topic, let me ask you this question. Why do we need electricity? Okay, so we need electricity because on a day-to-day basis, we rely, okay, mostly on our appliances, our gadgets, and it makes our life a much easier and comfortable. Okay, so everything we see, okay, in our households, okay, our light bulb, your laptops, your phones, everything is powered by electricity. And how do electricity works? Okay, so electricity came from various resources, okay? Just like, for example, geothermal power plants, hydrothermal power plants, everything that can be renewed and transformed into a kind of energy we know as electrical energy, okay? So according to the first law of thermodynamics, okay, which also known as law of conservation of energy, it states that energy can neither be created nor destroyed, but can be transformed into one form or another. Okay, so from um, thermal energy, from geothermal and hydrothermal energy, electricity is created and electricity is distributed uh, to our households and to um, establishments. Okay, and then this electricity, this electrical energy, is transformed again into different various objectives of our specific appliances. For example, our electric fan. Okay, so from electrical energy, natatransform siya into mechanical energy. And then yung refrigerator natin and yung aircons natin into thermal energy. Okay, so under applying law of thermodynamics. So how electricity works, in studying electricity, papasok dito yung understanding natin of two different types of circuits. Okay? So we have closed circuit and open circuit. So the difference between these two types of circuit is that in a closed circuit, the current flows continuously following the track or the loop of our circuit. Okay? So from the source, the voltage source to the load, which in this example, the LED light or the LED light, and then going back, okay, to our power source, which is our dry cell here or the battery. On the other hand, open circuit is this is a kind of circuit that current or there is no route which the electrons are flowing. Okay, so the action or the motion of electrons flowing in the circuit is what we know as current. Okay, so current is the motion of since we know that current is the motion of electrons within a circuit, so it is a flowing of electrons. Okay, so we have two types of or two orientations of how current flows in a given circuit. Okay, so first we have electron flow and second we have conventional current flow. What is the difference between these two classes of current flow? On an electron flow, we take into consideration our electrons. In nature, okay, electrons are negatively charged. Okay, so the starting position of where electrons flow is from the negative terminal of our source, okay, our battery here, towards the positive terminal of our supply. Okay, that is how electron flows from positive to or rather from negative to positive. On the other hand, we have conventional current flow. So conventional current flow is the opposite of electron flow. It is the considering how positive charges or positive electrons flow in a given circuit. So it starts from conventional current flows. It starts from the positive side of our supply towards the negative side of our source or our battery. So in circuit analysis, we would be using um, conventional current analysis on how current flows on a given circuit. But in reality, okay, since ang definition po natin ng current is flow of electrons. Okay, flow of electrons. So in reality, it is electron flow. Pero to analyze a specific flow of current in a given circuit, we would be using conventional from positive to negative. Okay, so as we define current is a motion of charge from one region to another. To mathematically describe that phenomenon, we use this equation I, which is our current measured in amperes, okay, named after who discovered current, which is Andre Marie Ampere, equals to charge coulomb and over time seconds. Okay, so based from this formula, 1 ampere is equals to 1 coulomb per second. Okay, so current is the measurement of how much charge in coulombs traveled over a given period of time. Okay, so this is the relationship between our mathematical formula and the two types of current flow. On the first diagram, okay, this is an example of conventional current flow. Okay, as you can see, the charges here starts from positive to negative. Okay, likewise, okay, on our second diagram, example po ito ng election flow. Kasi po, makikita natin, nag-start po yung ating mga charges from negative to positive. But both do represents how current flows in a given circuit, okay, mathematically defined by I is equals to change or delta Q over delta T. Okay, so we have two different types of current, okay, given in a circuit. So we have DC current and AC current. What is the difference, or what is the meaning of these two acronyms? DC stands for direct current, okay, and AC stands for alternating current. Okay, so saan sila ginagamit? Okay, DC current is basically used on low voltage appliance. For example, your phones, tablets, laptops, basta nagko-consume ng mas maliit na voltage, ang ginagamit po natin dyan ay DC. Okay, on the other hand, yung AC supply or alternating current is used on a large scale consumption. Okay, for example, your home, okay, yung nakikita natin sa mga saksakan natin, 220 volts rating yan, pero AC. Tapos, sa power plants, okay, sa mga poste, basta mas madami ang kumukonsumo sa kanila. Bakit po, sa maliit lang na voltage makikita si DC at large scale naman si AC? Kasi if you were going to refer to our diagram, so makikita nyo, continuous yung flow ng electrons natin. So, kung i-graph natin, this is horizontal line, okay? Straight line, continuous. And the downfall or the downside of this type of current is that, okay, since continuous na po siya, nauubos, okay? Nauubos yung laman ng ating source. Okay? Kasi kinukonsume po natin siya all throughout. Okay? So, if yung appliance niyo po ay hindi lifetime, okay, yung power source niya, so meaning, ang ginagamit niya po ay DC, katulad ng phone natin, nalulubat, okay, nadi-discharge, so kailangan natin siya i-charge. So meaning, DC po ang ginagamit ni phone. Okay, sa AC naman, kung i-compare natin yung flow of electrons niya, makikita niyo siya pabalik-balik. So, kung i-graph natin siya, ang magiging graph niya is sinusoidal. So, kapag sinusoidal yung graph natin, so, magiging conception natin dito is yung source natin is continuous or meron siyang possibility na magbigay ng fluctuation sa'yo at all throughout your use of that specific appliance. Magkakaroon ka ng supply. So, hindi siya nauubos. Wala siyang limit. Unless, puputunin mo siya dun sa main source or your power breaker or masisira yung poste nyo, yung linya ng kuryente. So, yun po. Yung pinagkaiba ng AC and DC. So, si AC, siya po yung example ng current na may kakayahan kung makapag-electrocute or makakuryente sa atin. Kasi on a large scale basis po siya. Okay? So, that's how current works and the difference of flow currents applied on a specific gadget or appliance. Okay? So, since we discussed voltage on our previous discussion, we know that it is the stored energy. Okay? And then, now, na-discuss na po natin yung current. Okay? So, yung last na factor na matatagpuan natin sa electricity is what I call as resistance. Okay? So, the resistance is the measurement of how a specific circuit or how a specific material or component could resist the flow of current. Okay? So, resistance mathematically is equals to the ratio of voltage and current. So, resistance measured for the unit used is this Greek sign omega, okay, read as ohm. Okay, so equal po siya sa voltage over current. So, di ba meron po tayong dalawang klase ng material? Okay, we have a conducting material and we have an insulating material. Okay, at a insulating material, siya po yung material na meron or mama-measure po tayo ng high value of resistance. Kasi ano po ba ang insulating material? So, it doesn't allow current to flow. On the other hand, yung conductors naman, okay, siya yung may pinakamaliit na values of resistance. Okay, kasi conductors allow electricity to flow on a given circuit. Okay, so the measurement of the conductivity of a material or a specific conductor is measured in conductance, G. Okay, capital letter G. So, ito yung kabaliktaran ng resistance. So, since opposite siya ng resistance, ang equation niya is 1 over R. So, ano yung unit na ginagamit kay conductance? So, yung ginagamit sa kanya, since kabaliktaran nga siya ng resistance, since ito ay ohm, ito yung unit na ginagamit, tapos it is read as mho. Okay, so, mas madaling tandaan. So, conductance is the measurement of how conductive is that specific material. Okay, so on in order for us to physically illustrate the capacity of a uh, material or a specific component to resist current flow, gumagamit po tayo ng resistors. Okay, this is an example of resistor. So as you can see, para lang siyang maliit na candy with color strips. Okay, na nakalagay po dun sa physical appearance niya. The color strips of the resistors indicates the value of that specific resistor or the value of the resistance of that specific resistor. Okay, so pwede po mag-rely dito sa table. Okay, para malaman yung values ng resistance. Okay, so the resistance of an object doesn't limit lang sa mga resistors. Even our skin, okay, yung katawan po natin as a human, meron din po tayo individual resistance. Under dry conditions, the resistance offered by the human body may be as high as 100,000 ohms or 100 kilo ohms. If your skin is moist or it is wet or broken, it may drop your body's resistance to 1 kilo ohm. Adding that high voltage electrical energy quickly beats down human skin, reducing human body's resistance to 500 ohms. Okay, so since alam po natin, hindi nalilimit lang ang resistance sa resistors, even humans, meron din po yung resistance. Okay, so para ma-compute po natin ang specific resistance ng isang material, okay, we use this formula. So R is the resistance. Rho here, okay, this is read as Rho, okay, is the resistivity of a material and the ratio of the magnitudes of electric field and current density. So as we know, good conductors have a small resistivity and good insulators have large resistivity. So we have different values of resistivity depending on which material we are using on a circuit. Okay, L stands for the length of our material. Okay, basically we use wire or cylindrical material kasi yun naman yung madalas natin natatagpuan sa mga circuit. And then A here is the area of that specific wire. Okay, so based from this formula, resistance is equals to Rho multiplied by L over A. So makikita po natin that the resistance of a specific material depends on the type of material used, okay, the resistivity factor, the size of our material used, the length, okay, and then the shape, okay, kita natin yung area. Okay, so based from this formula, we can conclude that the resistance of a specific material depends on the type of material, size, shape. So may nakalagay dito temperature. So how does temperature, okay, so affects the value of the resistance of the object? Okay, temperature dependence of the resistance. In order for us to indicate the effect of the temperature to the resistance value of that specific object or material, we use this equation. R sub T is also R sub naught multiplied by 1 plus alpha delta T. So if we are to expound this expression, R sub T is equals to R sub naught multiplied by 1 plus delta alpha, okay, times final temperature minus initial temperature T naught. Okay, so what are these values? So R sub T is the resistance after there is a change in temperature. R sub naught is the resistance before the change in temperature. Alpha is the temperature coefficient and delta T is the change in temperature. So, bakit po ba nagbabago ang resistance natin kapag nagbabago din ng temperatura? Kasi atoms inside our materials, its speed increases. When the speed increases, it increases its vibrations. Okay, the vibrations, okay, affects the value of the resistance. So we could conclude that when the temperature is increasing, okay, there is also an increase of um, the value of resistance. Okay, so take a look on this table on the right part of your screens. Makikita natin dito yung values ng mga resistivity raw at saka ng temperature coefficient alpha of specific material, especially here mga metals. Kasi metals naman yung ginagamit natin for a circuit, especially wires. Okay, so yung silver, copper, gold, aluminum, and etc. So, ano po ba yung madalas na ginagamit natin sa wire? So, yung copper. So, copper is or has a resistivity factor of 1.7 times 10 raised to negative 8, and then may temperature coefficient po siya na 3.9 times 10 raised to negative 3. So, you may base on this table, depending po kung ano po yung ginamit mong material for the conductive material, ginamit mong material para sa mga wires. Okay? So for metals, okay, since metal yung given natin dito halos lahat, as temperature increases, the resistance also increases. At a very low temperature, so kapag mababa yung temperature natin, resistance can become zero. Bumababa din yung resistance natin. Okay? So kapag wala po tayong na-measure na resistance sa isang object or sa isang material, ibig sabihin po, yung material na yon is very conductive. So tinatawag po siyang superconductors or because it has the effect of, or it has the ability to do not resist, okay? So, or everything, or every current or every electron passes on its material. So, for semiconductors, on the other hand, for semiconductors, the opposite occurs. Okay, so pag mababa yung resistance, or sorry, pag mababa yung temperature, mataas yung resistance. So, ibig sabihin yung material na yun is superconductor. Okay, since we discussed voltage, current, and now resistance. So those three factors do have a relationship regarding how we utilize electricity on a given circuit. Okay, that the relationship of those three factors is included on the law, okay, made by George Simon Ohm, okay, which we know as Ohm's law. Okay, it is the relationship between voltage, current, and resistance in any DC electrical circuit. Okay, take note, DC meaning sa direct current lang po ito na-apply. So, ibang law yung magagamit natin sa relationship ng voltage, current, and resistance on an AC circuit. Okay, so according to Ohm's law, he said that current I is equals to the ratio of voltage V and resistance R. Okay, to give you a glimpse of the relationship between these three factors, you may refer to this diagram. Okay, so makikita natin, voltage is is a force, or is the one who's responsible of pushing the electrons to flow, which is the current, and the resistance ohm is the one who limits the amount of current that passes through a given component or a given load. Okay, so Ohm's law, yan, since itong tatlong to yung factors natin, yung kita natin, so pwede na tayo mag-rely dito sa Ohm's law triangle para mahanap po natin yung specific ano. So takpan nyo lang yung hinahanap and you may refer, okay, to this triangle. Okay, so since nabanggit po natin dito yung current and voltage, okay, current and voltage can be found in our sources. So ano yung tawag natin dun sa sources natin? So tinatawag po natin siya power sources. Ano po ba ang power? Power is, in a circuit, is the amount of energy that is absorbed or produced within the circuit. So mathematically, power, okay, measured in watts, capital letter W, is equals to voltage times current, okay, or IV. So pwede rin po tayo mag-refer dito sa power triangle in computing for the unknowns. Okay, if we are going to relate Ohm's law and power equation into one specific diagram, so pwede tayong mag-refer, okay, dito sa ating Ohm's law pie chart. So hindi na tayo kailangan mag-derive, okay? If ever na ang need mo sa problem is power, okay? So ito yung tatlong equation niya, okay? In relation with Ohm's law. Okay, since now, discuss na natin lahat ng needed equations natin. Let us try this or what we have discussed on this problem. Okay, so a 1.5 meter cylindrical rod of diameter 0.500 centimeter is connected to a power supply that maintains and contains a constant potential difference of 50 15.0 volts across its ends, while an ammeter measures the current through it. We observe that at room temperature 20.0 degrees Celsius, the ammeter reads 18.5 amperes, while at 92 degrees Celsius, it reads 7.2 amperes. You can ignore any thermal expansion of the rod. Find the resistivity at 20 degrees Celsius and the temperature coefficient of resistivity of the material of the rods. Okay, so let us write all of our givens. Okay, so meron tayong length na 1.5 meters. Tapos diameter of our rod is 0.500 centimeters. So we convert na natin sa SI unit, 0.00500 meters. And then we have a voltage source of 15.0 volts, while an ammeter, so meron daw tayong temperature T0 of 20.0 degrees Celsius. So ang nabasa daw niyang current not is 18.5 amperes. Okay, so TF at 92 degrees Celsius, ang current reading daw is 7.2 amperes. So we are going to ignore any thermal expansion here. So what is the resistivity at 20 degrees Celsius? So resistivity rho. Okay? So ang una natin dito gawin is to use Ohm's law for us to compute for the resistance. Okay, resistance R is equals to V over I. Okay? So at 20 degrees. So ang voltage natin is 15 volts. Tapos at 20 degrees, ang current daw natin is 18.5 amperes. So ang resistance at 20 is equals to 0.811 ohms. Okay, so we can compute the resistivity using the equation R is equals to rho L over A. So if we are going to rearrange this formula, okay, since nahanap natin ay rho is equals to RA over L. Okay, so substitute natin yung mga given, 0.811 ohms. Okay, multiply by the area. Since ang area po natin is cylinder, yan, cylindrical rod daw siya. Okay, using the diameter D over 2, okay, square. Okay, substitute na natin yan. So 0.00500 meters over 2 square. Okay, and then divided by the length. Okay, don't forget the pi here, pi. Okay, pi. Okay, divided by the length, which is 1.5 meters. Okay, kasi ano po ba ang area ng cylinder? It is pi r squared. Okay, so d over 2 is the r and then squared. Supposedly pala ay nasa labas ng pi. One 1.5 meter. So, makakompute po natin rho dito at 20 is equals to 1.06 times 10 raised to negative 5 ohm meter. Okay, so yun yung resistivity at 20 degrees Celsius. Okay, so second po is what is the temperature coefficient of resistivity for the material of the rod. Okay, since hinahanap is temperature coefficient, so iti-take into consideration natin yung pagbabago from 20 degrees Celsius to 92 degrees Celsius. Okay, so meron na tayong resistance ng at 20 degrees. So it is equals to 0.811. So how about at 92 degrees? So V R at 92, okay, is equals to V over I. Yan. So 15. So nagbago yung current niya, naging 7.2 amperes volts. Okay, so resistance at 92 degrees is equals to 0.872 ohms. Okay, so ito yung RF. So since meron na tayong resistance before and after, we could use this equation in order for us to get the temperature coefficient alpha. Okay, so RT is equals to R naught multiplied by 1 plus alpha, okay, AF minus T. Okay, substitute lang natin mga na-compute natin. RTs are at 92, 0.872 is equals to 0.811 multiplied by 1. The alpha is our unknown for the temperature coefficient. So 92 minus 20. So alpha or temperature coefficient is equal to 0.00105 degrees Celsius. Okay, so that would be all for this problem. Okay, so